Hello and good evening. This video tutorial is going to be on OSPF authentication. Typically students become a little confused and have a number of questions regarding OSPF authentication, the three different types, and we're going to take a look at each. We're going to take a look at the null authentication, which is by default when you set up OSPF and establish adjacencies, you're using null authentication, which is basically no authentication. We're going to take a look at simple password authentication, and then we're going to take a look at MD5 authentication. And one of the most confusing things for students at the CCNA level is understanding the two different ways to do authentication setup in OSPFv2 with IPv4. And we're going to be focusing on IPv4 in this video tutorial. So the first method that you can set up authentication is that we refer to it as globally setting up authentication, where you have the message, if you're using MD5, you would have your message digest key, or you would have your authentication key under the interface configuration mode, and you would set up the area, and we'll say we're going to be using area 0 tonight, the area 0 authentication under the global router config. And so we're going to do that on router 1, and then on routers 4 and router 6, we're going to do everything, or the majority of the configuration, simply under the interface, right? So we're going to set up the IP OSPF authentication, or the authentication, or the message digest keys, as well as the authentication message digest when we're using MD5. And so we're going to walk through examples of each of these. So as you can see down here, it's VLAN 146, where we've got three routers, router 6, router 4, and router 1. And these are all in the 155.1.146.0/24 subnet. And so let's go ahead and jump right in here. We'll start out on router 1. And it looks like router 1, that's right, I was clearing router 1 up. So router 4 is ready to go. Let's come back over here to router 1, which should be up rather quick. Again, this is being done in software. It's not actually on physical hardware. So let's make sure show run section OSPF. Whoops. OSPF. No regular expressions. All right, good. So the configuration's been cleared out. All right, so we're going to start out with null authentication. We're just going to make sure we can get our adjacencies up. And when working with OSPF authentication, and I've had this happen, you can run into unexpected results if you try to set the authentication up before you establish the adjacencies. So it's highly recommended that you establish the OSPF adjacencies and make those configuration changes first, confirm and verify that the neighbor relationships are up, the adjacencies are there and established prior to layering on authentication. All right, so let's go ahead and jump right in. We'll go from privilege exec to global config, and I'm going to go into the router OSPF. We're going to say the process ID is just going to be 1, and the first thing I'm going to do is I'll set the router ID to 1.1.1.1. Once I've done that, we're going to go ahead and add a network statement for 155.1.146.0 with a wildcard mask of 0.0.0.255, and that is going to be, that interface is going to be in area 0. All right, so now we're going to go ahead and once this is done, we're going to go ahead and we're going to jump onto router 6, or I should say router 4 and router 6. All right, so on router 4, and I want to make sure, let's make sure that we do a do debug IP OSPF adjacency. And we want to see what's happening here because we're actually going to be able to gather some very detailed information about the neighbor relationship and specifically the authentication types. All right, so do debug IP OSPF adjacency. And we'll do the the same thing here on router 6. Do debug IP OSPF adjacency. Whoops. All right. So we have debugging on for OSPF adjacencies. And as you can see here, router 1, since I've already started the OSPF process on Ethernet 00, he's gone out and elected himself as the DR. So let's go ahead and jump into the configuration here on router 4. So router OSPF. And the key thing to remember here is the process ID number. Remember that this is a locally significant number. And so here's what we'll do. So we're just going to keep the process ID number the same as the router host name. So router 1 will be OSPF process 1. Router 4 is going to be process ID 4, and 6 will be 6. And this is just to show that, again, this is a locally significant number. So router OSPF 4, so we'll set our router ID to 4.4.4.4. And what we're going to do here is, remember, for router 4 and 6, we're going to do as much of the configuration under the interface as we possibly can. And so we're going to go ahead and let's do show IP interface brief to make sure we get the right interface, which is going to be Ethernet 01. So interface Ethernet 0/1. And I'm going to say IP OSPF. And the process ID is 4 because we're on router 4, and area 0. And we should see some debugging messages here. And again, this is going to be process ID 4 on this router. All right, and this happened rather quick, and you can see that it went from loading to full. So if I were to type in here, do show IP OSPF neighbor, NEIGH, you can see that router 4 has established an adjacency with router 1. And now we're going to go ahead and we'll jump over here to router 6. So let's make sure we get OSPF up and running here on router 6. So we'll say conft, we'll go router OSPF 6. And again, using different process IDs on each of the 3 routers to really drive home the fact that the process ID is locally significant. Not like EIGRP. Remember, EIGRP, it's not a process ID, it's an autonomous system number. And those need to be the same if you want them to establish neighbor relationships. All right, so our router ID is going to be 6.6.6.6, and we're going to do the same thing on router 6. We're going to make the OSPF, or we're going to activate OSPF on the interface. And so let's do show IP interface brief. And this is running on Ethernet 0/0.146 subinterface. And we're going to say IP OSPF 6, and this is going to be area 0. And so we would anticipate that we're going to see some activity here from both router 1 as well as router 4 while these adjacencies establish. So if I do show IP OSPF neighbor, you can clearly see here that router 6 now has an adjacency with router 1 and router 4. He sees router 1 as the DR and router 4 as the BDR. And let's see what router 4 sees now. So he sees router 1 as the DR, and router 6 is just simply DR other. And remember, we've set the router ID, so it's the lowest router ID that is typically, whoops, and the debugging is already on, so I wanted to see, do show IP OSPF neighbor. All right, so our neighbor relationships have been established. So router 1, router 4, and router 6 all have adjacencies with each other. The DR, BDR elections have taken place, and so you can really say at this point we have done null authentication in our OSPF setup, which is basically no authentication. And so what we're going to do now is we're going to go ahead and take the next step, and we're going to do what would be referred to as the simple authentication. And so once we establish, or once we go to set this up, you're going to start seeing debug messages. They're going to provide us a lot of detailed information with respect to the authentication mismatches that are going to occur while we're getting this configured. Okay, so right now we have no authentication. So let's go ahead on router 1 and we're going to go ahead and set up authentication by making a global router config change here, right? Where we're going to say area 0. And if you look here, we have authentication. And so once I type that in, if I wanted to use MD5, I could. That's the third type of authentication, so we're not going to do that quite yet. So if I just leave it like this, you can see that the CR for the carriage return, that this is a valid location for me to simply hit enter. Now when I do this, we should start to see debug messages that are going to indicate that we've got an authentication mismatch. Because remember, router 1, we've globally configured OSPF in the router global config section, right? So I'm going to go ahead and hit enter. And so what I've said here is that immediately we're going to start to receive messages from both router 4 and router 6. So if I were to say do you, whoops, all, so we're going to turn debugging off, and we can see right away that router 4 and router 6 are both unhappy with the fact that they are not set up for authentication, but router 1 is. And so router 1 right now is seeing, you can see here that it's actually transitioned to down, right? From full to down. The state machine has the state machine has torn down the neighbor adjacencies. So if I were to do a do show IP OSPF neighbor at this point, our neighbor relationships are gone, right? So they're down. And the reason that they're down is because routers 6 and 4 are not set up for simple authentication, they're set up for null authentication. And if you remember, we said type 0 authentication is the null authentication. So router 1 is logging a message here. It says input packet specified type 0. We use type 1. And so type 1 authentication is the simple password authentication. And that's what we're using on router 1. Routers 4 and 6 are not. So let's go ahead and do the next step on router 1, and that's going to be to set up an authentication key. And specifically, the authentication key in this context is just going to be the password that we're going to use. Because we have authentication on, but we have to provide some sort of a password between the two routers that's going to be used as our key. And so, let me take a look at the interfaces again here to make sure I've got this right. So Ethernet 00. So if I go to Ethernet 0/0, and right now under the interface, I can set up the IP OSPF, and there's our authentication key. So authentication key, and this is where I would put in the password, and again, simple password. So let's just say IP OSPF authentication key Cisco, right? And so again, this is sort of the first way that you can set up authentication. And to be clear, the two different methods, to talk about the two different methods for a second, the first method, which we're doing on router 1, we're setting up under the router global config mode, or the OSPF router configuration mode. We're setting up the area 0 authentication command, and that is globally enabling authentication on the router. And then under the interface, I'm specifying my authentication key. In this instance, it's Cisco, and that's just simply our password. So for router 1, this is one way to do it. Now, we're doing it with simple authentication. We're going to see here soon that you can actually do this exact same thing on router 1, and as you saw, we could do MD5 authentication. So the first way to set up authentication with OSPF is to declare show run section OSPF. So the first way to do it is to declare under the router config section that we are doing area 0 authentication, and then under the interface to specify the password. and this would be the simple authentication. So that's the first way that you can do it, and you can do it with simple authentication, and you can also do this exact same thing with MD5 authentication. So let's come over to router 4 and router 6 now, and let me turn debugging back on, do debug IP OSPF adjacency, because we want to make sure that we're seeing what's happening here. So we've transitioned from null authentication to simple authentication on router 1, and we know that that's what's happening because router 4 and router 6 are not happy with the authentication type. You can see there's a mismatch, and our adjacency right now on router 1 is down. So let's address that. Let's come over here to router 4, where I'm going to say do you all. We're going to turn debugging off right now, and you can see that router 4 is also logging messages indicating that it is having a mismatch authentication type. The input packet specified is type 1, so the input packet it's receiving from router 1 is indicating it's using type 1 authentication, which is simple password authentication. However, router 4 is saying we are using type 0. We're not using authentication. We're using null authentication. Okay, so let's go ahead and again, remember, for router 4 and router 6, we're going to do everything that we possibly can under the interfaces. So if I do a do show IP interface brief, let's make sure we're in the right interface here. It's going to be Ethernet 0/1, and do show run int Ethernet 0/1. So right now we just simply have the IP OSPF4 area 0 command. If I do a do show run section OSPF, you can see that here on router 4 we have not placed the command area 0 authentication. So we're going to do that. We're going to do everything under the interface, and so this is actually the second method to enable and configure authentication within OSPF, and it's basically doing both configuration pieces under the interface configuration mode. And so let's go ahead and get that set up. So we've got the IP OSPF4 area 0 command. Now if I do IP OSPF, you can see where, whoops, we can say authentication, and again, we can go ahead and hit the carriage return, right? Because we're doing simple authentication, okay? We're not doing message digest authentication, at least not yet. So I'm going to say IP OSPF authentication, and so if I come over here to router 1, we should still be receiving for both router 4 and router 6, we should still be receiving, I shouldn't say receiving messages, but generating messages on router 1. And let me go ahead and do a do you all and kill debugging, and let's take a look at what's changed here now. Whereas prior to this, prior to that command that we just ran on router 4, we were seeing mismatch authentication type, and then it would tell us input packet specified type 0, we use type 1. Now what we're seeing is mismatched authentication key, clear text. So we have a mismatch authentication key. So remember on router 1, under the interface, and if I do show run, and I believe it's interface Ethernet 00, you can see that we have an authentication key of Cisco. In other words, you can think of it as the password. The password is Cisco. Now, authentication's been turned on router 4. However, we have a mismatch authentication key. We have yet to set the authentication key on router 4. And so let's go ahead and set the authentication key on router 4 right now. So we're going to say IP OSPF, and there's the option for authentication key. And again, we can simply type in Cisco. And let me do a do debug IP OSPF adjacency. We're also going to see some messages over on router 1. And as you can see here, now that we've put the correct key in, what do we see now? Or the correct password, I should say. It's referred to as the key, but I typically call it a password. And so let's take a look now. So now we've jumped over here to take a look on router 6. Nothing's been done on router 6. It is using null authentication. And as you would expect, the messages that we're seeing on router 6 are indicating that he is receiving type 1 authentication messages, but he uses type 0. So router 4, right, mismatched authentication type with router 6, which is, we would expect that. Nothing's been done on router 6. And then over here, do debug IP OSPF adjacency. We should see some messages here in short term from router 6 as well. However, now that router 1 and router 4 have been properly configured for simple authentication, if I do a do show IP OSPF neighbor, whoops, you can see that that adjacency with router 4 and router 1 has now been reestablished. Okay? All right, so let's go ahead and let's jump on to router 6. And let's get router 6, and he'll be configured just like router 4 was configured. Remember, we're doing on 6 and 4, we're doing everything, or as much as we can, under the interface as compared to the global config mode. And again, this is the second method to setting up OSPF authentication. Remember, the first method we did on router 1, where we declared the authentication under the global router config mode, and then we set the key up under the interface. On 4 and 6, we're doing all of the authentication work under the interface. So we're here under the interface. I'm going to go ahead and say IP OSPF authentication, and that's going to turn authentication on. And so again, if you notice here, right, initially, before we ran that command, what we were seeing was a mismatch authentication type, because we had null authentication on 6, and we had simple authentication on routers 1 and 4. As soon as I enabled simple authentication under the interface on router 6, the messages have now changed, very similar to what we saw on router 4, to where the authentication type is not what the problem is anymore. The authentication key and the fact that it's mismatched, we have no authentication key on router 6, that's our problem now. So let's go ahead and do the IP OSPF authentication key, and we're going to set that to Cisco. And what we should see here is, and there it is rather quickly, is the adjacency relationship between router 6 and 4 and 1 is going to come back up. And if I were to now do a do show IP interface, do show IP OSPF neighbor, you can see that the neighbor relationship is up. If I do a do show IP OSPF interface, and I'm on 6, so this is going to be Ethernet 00.146. When we take a look at the interface, we can see some interesting information here, right? And we're coming down to the very bottom where we're seeing that simple password authentication is enabled. So if I were to pull this off, and let's say I typed in here no IP OSPF authentication and no IP OSPF authentication key Cisco, you can see that we're right back to the mismatched authentication type. However, when we look at the interface now, I'm going to turn debugging off, do you all, and I'm going to run that command again. Now when we take a look at the interface, you can see that when authentication in OSPF is not configured, it doesn't actually tell you, or it doesn't actually have a message in here that says, you know, authentication type null, right? So by default, if we don't do anything and we don't set authentication up, it's going to be null. Okay, so let's get that turned back on. So we're going to turn on IP OSPF authentication, and then we're going to get the key in here for Cisco, and then we should see rather quickly here that the adjacency is going to reestablish between router 6 and the other two routers, router 4 and router 1. Oops, and I have the key in there is incorrect. I apologize. And there we go. All right. So now that that's set up, and again, debugging is off here. If I come over here to 4, you can see there's all kinds of activity because 6 just rejoined the group with the proper authentication. He's now doing simple authentication. And again, if we take a look at the interface, right, the OSPF interface, this is where you're going to see that simple password authentication is enabled. All right, so now what we're going to do is we're going to transition. So we've looked at the first two types of authentication with OSPF. The first type of authentication is null, N-U-L-L, indicating that we have no authentication whatsoever. We've got that, we had that set up, and then we went ahead and layered on simple password authentication, which is where we just simply declare IP OSPF authentication, and then we add in an authentication key. And we know that we look at the interface here. If you look under the interface, you'll see that simple password authentication is enabled. All right, so let's go back over here to router 1, and now we're going to change things up a bit. We're going to go ahead and we're going to step this up to type 2 authentication, which is going to be MD5. All right, and so again, router 1, remember that router 1 is doing things in the first of the two ways we could do authentication. And remember that router 1 is doing authentication with a router global configuration command or a router configuration mode command to indicate that we're doing authentication, followed by the IP OSPF command under the interface. And so if I were to do a do show run section OSPF, you can see that we've got the area 0 authentication command. So I'm going to say router OSPF 1, and we're going to change the area 0 authentication now. And remember, we had a choice here where we could say message digest. So I'm going to type in area 0 authentication message digest. Now, this is changing the authentication type from type 1, which was the simple password authentication, to type 2. And if you take a look at the messages that we're receiving, you can see that we're getting messages here to the console that are indicating that, hey, we're receiving input packets that are type 1 authentication, simple password authentication. However, now we're using type 2 authentication. This is also going to be followed by the adjacency, the neighbor adjacencies going down, right? So if I type do show IP OSPF neighbor, you can see we no longer have a neighbor adjacency at all. So the neighbor relationships have gone down. What I'm going to do now is we're going to go ahead and go into the interface. So we'll say int Ethernet 00, because remember, if I do show run on Ethernet 00, oh sorry, do show run int Ethernet 00. This is where we had our IP OSPF authentication key, and now we need to change this guy because it's going to become a message digest key. So I'm going to go ahead and say no IP OSPF authentication key, and we're going to say IP OSPF message digest key, and we're going to give it, we're just going to say this is an identifier for the key because what we're going to do to wrap up at least this portion of the tutorial is we're going to change the key IDs. I'm going to show you how to change your keys and what happens when you change the keys and how you can do it in a seamless fashion. All right, so IP OSPF message digest key 1, and we're going to say it's going to use MD5, and I'm just simply going to go ahead and put the password in here as Cisco. All right, so on router 1, we're using type 2 OSPF authentication, which is MD5. Routers 4 and router 6, we haven't done anything yet, so we're going to jump over there right now. And you can see here it says send with youngest key 1, right? So it's sending key 1. which is the newest key, right? The most recently created key. And keep that in mind. So back here, we're going to say do you all. We're going to, whoops, do you all. We're going to turn debugging off right now. So we're under the interface mode here. So if I do a do show run section OSPF, you can see that, again, under the router config, router global config, all we have is the router ID configured in the OSPF process ID. It's under our interface where we've set up our authentication. And so we're currently in that, under that interface. So I'm going to change this up. We're going to say IP OSPF. We want to move to type 2 MD5 authentication. So we're going to say authentication, message digest, and we're going to hit enter. And then we're going to say no IP OSPF authentication key Cisco. Now we're going to say IP OSPF, message digest key, sorry about that, message digest key, and we're going to say that this is going to be key 1 MD5, and we're just going to say Cisco. All right, so now if we come back to router 1, you can see that router 1 and router 4 now have a lot of activity taking place between the two of them. And let's see if they've reestablished their adjacency. Show IP OSPF neighbor. And sure enough, router 1 and router 4 are now, once again, they've established a neighbor relationship, neighbor adjacency. However, router 6, where we've got a mismatched authentication type still, he's still using authentication type 1, which is simple password authentication. So let's go over to router 6, and let's make the same changes that we just made on router do show run int ethernet 00.146. Okay, and so we're going to say IP OSPF authentication. Oh, I apologize. IP OSPF authentication message digest, and we're going to pull off the simple authentication that we've configured, and we're going to replace that with MD5 authentication. So OSPF message digest authentication key 1 and MD5, and we're going to say Cisco. And now this should resolve the issue between routers 1 and 6 and 4 and 6. I think debugging is off here, so do debug IP OSPF adjacency. So we'll turn that back on for router 4. All right, so as you can see, do show IP OSPF adjacent or neighbors. You can see now that the neighbor relationship is back up between 1, 6, and 4. Do show IP OSPF neighbor between 1 and 6, or 1, 6, and 4 on that side, and then let me pull this back and say do show IP OSPF neighbor, and between 6, 1, and 4. So all of our neighbor adjacencies are there. We're currently using type 2 authentication, which is MD5 authentication. And so again, you've seen that the process IDs can be different on each of the routers. You can mix and match the OSPF authentication configuration methods. Keeping in mind the first method is to set up the area ID authentication in message digest if you're using MD5 under the router configuration mode, and then to set your key up under the interface. That's the first way to do it. The second way to do it, to give you a little more granular control, is to do both of those configuration pieces, both the IP OSPF authentication statement as well as the message digest key or your authentication key statement, to do both of them under the interface. So the only difference is you're doing one step under the global router config, whereas in the second method, both steps take place under the interface configuration mode. So what we're going to do now is, let's say that you wanted to change keys. Maybe you had an employee who left out and he knows what your authentication keys are, and you want to make sure that those are going to be encrypted. So if I do a do show run right now, we take a look, you can see that the MD5 hash is simply there in plain text. One of the things that you want to remember is if you do the service password encryption, whoops, let me end that here. So service, whoops, global config. So service password encryption. So if you set service password encryption, and now I do a do show run on interface Ethernet 00, you can see now that the password is a type 7 password. And so again, that's very easy to crack, but it prevents somebody from looking over your shoulder and seeing the password. All right, so let's say you want to change your key. So I'm going to go under interface Ethernet 00, and we're going to say IP OSPF message digest key, and this is going to be key 20, right? And you can pick random numbers, MD5, and you can see encryption, 0 for not encrypted, 7 for proprietary. And so we're going to go ahead and say this is going to be Juniper. Right? We'll make the password Juniper. Okay. So now under this interface, do show run int Ethernet 00. And I didn't spell that right. Ethernet 00. You can see we've got two keys now. We have key 1 and we have key 20. So this is how you can seamlessly switch the keys over. Now you'll notice the messages that you're seeing under the debug output here shows right now that I'm sending two keys. I'm sending key 1 and I'm sending key 20. So over here on R4, we're still using just key 1. And now we're receiving a message telling us there's a mismatched authentication key. However, the adjacency is still up. Do show IP OSPF neighbor. You can see that it's had no impact whatsoever because the key that we were using initially, that youngest key, is still configured on this interface. And so again, we're talking about a sort of a transition scenario here where, hey, you need to update the authentication keys on your routers within OSPF, and can you do that seamlessly? And the answer is yes. And so we're going to continue on with that right now. So IP OSPF message digest key is going to be, we said it was going to be 20, and the keys do need to match. So when you choose the key number, right, if you're going to go with a new key, it can't be 10, 20, 30 across the three routers. It needs to be 20, 20, 20. So it's not like the process ID, right? These keys need to have the same number. That's how they're being identified. So we'll say message digest 5, and then we're going to say Juniper. And so now you're going to see that it says send with youngest key 1. This should change now. And what we should start to see is that he's also going to be sending both keys. And as you can see right there, he's sending key 1 and key 20. Let's come back over to R1. And now this is all R1 is doing. He's sending with key 1 and key 20. So I'm going to come over here to router 6, and I'm going to do the same thing. IP OSPF, message digest key 20, MD5, Juniper. And so we're not debugging here on 6, but what you're going to see is sort of auto-magically, now that we've configured key 20 on all three of the routers, that's the youngest key. And what that means is that's the most recently configured key. And so now OSPF, and I should say the router itself, is smart enough to know, okay, now I'm only sending the youngest key because everybody in the area that I've got an adjacency with is also sending that same key. And so as you can see, it's no longer sending key 1. There's been no flapping of the OSPF adjacency. If I do a do show IP OSPF neighbor, the adjacencies are still there between all three of the routers, and the keys have seamlessly been changed. All right, so you would have to do a little cleanup, right? So we would want to say no IP OSPF message digest key 1 MD5. So now if I do a do show run int Ethernet 00, you can see that we only have key 20. So we've seamlessly transitioned to a new key. So I can clean this up on all of these interfaces here. So no IP OSPF message digest key 1 MD5. So now the key has been removed here. Do show run interface Ethernet. I believe this is 01, and it is. So he only has message digest key 20 there. And then on router 6, we're going to do the same thing. No IP OSPF message digest key 1 MD5. Do show run int Ethernet 00.146. And there you have it. So we've seamlessly transitioned all of our keys from key 1 to key 20. We never lost OSPF adjacencies or connectivity between the routers. And we've been able to make that change without having any impact to the environment. And so I'm going to go ahead and real quickly point out that MD5 authentication, or the MD5 algorithm, and this is actually recent here. So from April 2014, it talks about, it's at Cisco's website, it talks about next generation encryption. And that's what the follow-on video to this is going to talk about, because MD5 is listed as a void, right? And the alternative is SHA-256. And so you'll notice that you can actually now set up keychains with OSPF, because, let me see, do show version. And so this is as of 15.41T. So if you're running 15.41T, prior to that, the only option you had was to choose MD5 as sort of the most secure authentication method with OSPF. However, now with 15.41T, you can change the encryption scheme and you can use SHA-512, SHA-256, and so that definitely goes beyond the CCNA, probably into the CCIE realm. So I'm going to go ahead and stop the video here, and I'm going to post the follow-on video, which talks about setting up the keychains and using the SHA encryption, sort of, taking it to the next level. That'll be posted under the CCIE section of my YouTube channel. So again, this has been sort of a really nice review of the OSPF authentication methods. And so remember that there's three. There's null authentication, which is referred to as type 0, and we saw that in the debug messages. There's simple password authentication, which is referred to as type 1 authentication, and we saw that in the debug messages. And then the third and final authentication method is with MD5. So using MD5 message digest hash to go ahead and protect your OSPF setup and your adjacencies between neighbors. We also took a look at the two different ways to set up OSPF authentication. We looked at the first, where we make the authentication declaration under the router configuration mode, followed by the key being set under the interface, and that was one way to do it. The second way, which gives you a little more flexibility and that will override the first method, is to do both of those things under the interface. Specifically, declare the authentication as being on under the interface, and then to declare your key under the interface. And so router 1 we did as a legacy method, routers 4 and 6 we did as sort of the new, more flexible method, trying to do as much under the interface as possible. All right, well, I hope you've enjoyed this video, and hopefully you know a little bit more about OSPF authentication, the different methods, the different types of algorithms that you can use, and we're going to go ahead now and move on to a little more complex topic, which is going to be using different encryption schemes and using keychains. All right, thank you for watching, and have a great night.